Hi, my name is Mahla. I'm a data scientist at Grain Data Solutions. In this video, I try to answer this question with minimum technical jargons. I'll start with defining the challenge. Then I'll explain a data science approach for that. And finally, I'll show its application on a case study. There are many factors that shape the yield. Some of them are numbers, like the amount of fertilizers or the space between rows. But many of them, and actually most of them, are spread over time. They are called time series in data science. A farmer that uses precision ag tools collects temporal data like temperature, wind speed, solar radiation, and soil moisture from multiple sensors in one farming season. They make big effects on yield, but they are collected from different farming seasons ending in different yields. Now, based on all of these, how could we predict yield for this year? An easy way is to compare averages from the past seasons. Here is the problem. Using average and standard deviation means you lose too much details about your data. As an example, look at these two hypothetical moisture profiles. They have the same average and standard deviation but opposite trends. Do they affect crops the same way? Probably not, because the timing matters, and farmers and agronomists know that. There are also other factors that should be considered while dealing with temporal patterns in ag data. First of all, farming data could have different start and end from one season to another, so length of farming seasons are not the same. Second, they could have different time intervals. For instance, your temperature sensor might read every minute, while your moisture sensor could read every hour or every day. Third, sensors could malfunction, misread, or go off, so you need to deal with many null values, outliers, and errors. As a result, any data science solution should take into account all of these factors. One good solution for such complex problem is a method called dynamic time warping, or DTW. It's a data science approach widely used in finance for predictions and finding trends. It's very applicable to ag problems. The intuition behind DTW is finding similarities for all of those temporal features among farming seasons. Let's go back to our question. Could historical condition of a farm indicate upcoming yield? Let's say a farmer collected data from the farm this season but does not know what yield will get. Also, the farmer has the historical data of the farm, and each past farming season has a known yield. Let's see how DTW helps answering this question on an actual farming data to predict yield. Data for this case study obtained from USDA Ag Data Commons. It is open to public, so I can share its analysis with you. Researchers applied different soil moisture stresses to corn over years, so they created lots of variation. Other contributing factors such as precipitation, solar radiation, wind speed, and temperature. After cleaning, exploring, and visualizing the data, we applied DTW approach to predict yield. For most farming experiments in this case study, DTW predicted the yield of corn with an error less than 10%. It shows that historical condition of plants is a good indicator of their future outputs. If we can find the farming season that is most similar to this season mathematically, then the yield should be similar too, and we can predict it with an accuracy much better than using average. To sum it up, data science offers predictability and helps farmers to have realistic estimate of the upcoming yield, even if their input data is complex and high-dimensional. Thanks for watching. You can find the link to the original post and dataset in the description below. Stay tuned for more videos on application of data science in agriculture.